It's sort of a figure eight on a, if you trace it over a year on a piece of paper.
Hey, everybody. I think there's a little red thing up on the screen that says we're on live right now on this 6th or 26th day of June in the year of our Lord 2023 through July 2nd. Welcome aboard our club's weekly trip into space. We call it the SBAU Astro Hour, and I'm Ron Heron, your host. We do it live every Monday morning from our home, 11 to noon. For a long time, Astronomy and Telescope Club, serving Santa Barbara, California, based in our beautiful Museum of Natural History. We call it the Santa Barbara Astronomical Unit, which, in case you're new to astrophysics, means the distance between the sun and the Earth. You won't believe how many trips around that sun our president has gone in his life. Check out our club on sbau.org. Oh, heck, just come join us. First Friday meetings. It'll be the 7th of July, a couple Fridays away. A young man named Sahil Hegde, UCSB student on his way, not UCSB, UCLA, grad student. Today, we're going to look at Mars from the atmospheric point of view. NASA's out there orbiting. Our moon hit first quarter early this morning. Different moons around giants out there. The gas people, Saturn and Jupiter, are doing their own thing. They have different new moons and old moons and whatever moons. We're going to check that out. NASA, let's see. Our solar system, we're going to take you out to the big eggshell, the Oort cloud. I understand we're about to hatch. Okay, Milky Way is in our news today. There's a new comet we're going to look at, dimming supernova. Ooh, and an eclipsing binary, plus some silly science cartoons. Let's meet the president. Happy birthday, Jerry Wilson.
Hello, good morning. Thank you.
Don't want to embarrass you since we were talking about ages of the universe and yours doesn't quite compare. But anyway, Jerry.
I remember them well.
Your wife, Pat, is really putting together a good party. Also married to a Pat, who happens to be our merchandise manager, as our outreach coordinator, Chuck McPartland, in front of the Ukraine flag to report, hopefully, about what's been going on lately, Refugio Beach and Canyon and areas like that. Here's Tom Whittemore on our screen, married to
Morning.
Pauline. He edits our newsletter and spent many years out there teaching them science at Westmont College in their big lab. One of our big full-time active members, supporters, and also runs the Santa Barbara Theater Organ Society, Bruce Murdoch, is with us today. He's married to Bonnie. Thank you, gentlemen. Let's start the hour off with a little silliness here, because we all got these forwarded cartoons and plus one video. I doubt we're going to watch that, but here it comes. These are the stick figures from hell. Happy summer solstice, says one. The girl stick figure says only 6 days until the latest sunset of the year. And this other guy says, wait, what? When I finally finish building my giant engine capable of shifting the Earth's orbit, this is the first thing I'm fixing. Tom Whittemore, did you want to say anything about that? You told us the longest or latest sunset is coming up, didn't you?
Yeah, it's tomorrow. Turns out it's tomorrow, yeah.
It'd make a good topic, but I probably would still not see it. Nevertheless, I get it. Summer solstice. Did any of you see the parade?
No,
Not in
No.
person.
Our connection, is Tessa. She probably missed it. Maybe she saw it, wasn't in it. Okay,
I
what do
asked
we?
her at the last meeting if she was going to put her big costume on, that big thing she wears that looks like a
Oh,
giant.
Tessa? Yeah.
Yeah,
The,
but she said no, she wasn't going to.
the big sun, whatever it is. It's a sun, a walking sunshine or whatever.
Yeah.
All right, here we have the dinosaur getting very paranoid, and in the background, some of the early mammals says, he does this every time there's a meteor shower. 65 million years ago. This one, I think I finally got this one. Oh yeah, the evolution of the cat. I'll just get some food from that camp. What could possibly go wrong? 10,000 years later, here's what it is morphed into. And here we are, I think, on the moon. Oh yeah, this could happen. It's something they're going to have to watch out for. The guy standing outside the LEM in his spacesuit. Man, is this low gravity? I feel like I can
I like
lift
this one,
anything. I bet I could even lift up this ship, and he does. And there goes his ride.
And that's actually not really physically
Possible.
correct, but it's fun.
Well, I wonder how all those people that say we didn't land on the moon explain those bouncing around, that Neil and Buzz did. Here we go. This is scientist hell. The psychics, astrologists, mediums meeting for eternal discussion. You can just
Actually,
imagine.
that last thing where the guy lifts his spaceship could happen if he landed on Phobos or Deimos.
Well, I don't know. Could he
Well,
lift-
it still has a lot of mass.
well, we're gonna have
Right,
to
but
talk
doesn't
about it.
take-
Yeah, it has a lot of inertia.
Yeah.
If you add it to your talking points, Jerry. There's not enough to talk about. Here's a Far Side cartoon. Oh, it's the guy. The rest of us have pens in the pocket. This guy says, once again, Vernon has a good shirt ruined.
Oh, everybody's got an octopus in there.
Well, I wish I had time to tell you about the time I took an octopus, believe it or not, down to Cal Worthington to be his 8-legged dog Spot. And
Huh.
the thing inked inside the big bag of seawater, and you couldn't even see it and it wouldn't move. Academic translator, you want to tell us what the academics say is on the left side column, what they actually mean. For example, various sources means, I forgot the name and the author of that one paper. And there's others there. You want to pick out one and read one, gentlemen? Your favorites?
More research is required means I need funding.
Okay.
Here's the last one. The notes were meticulously transcribed. I was drunk and missed out at least 7 pages.
But that's not the last cartoon. Here's one.
No.
What do we got? Dad talking to his son at the table. Oh, you're gonna have to explain this one. It's a cat joke. Another Schrodinger's cat cartoon. That joke's been done to death. Or wait a minute, has it been done to death? Now, is what the son doing, drinking his coffee, and I assume that's his boy. Does that have anything to do with this? What's the
No.
Schrodinger's cat connection?
No, he's just musing to himself about the uncertainty of the cats dying, and he says, and he's uncertain about whether the joke's been done to death or not.
Okay, it's the uncertainty principle. Okay. Here comes a guy being rescued, almost thinks he's being rescued on that one palm tree, desert island. And it sweeps in, thank God I'm saved. And it's a UFO that takes the one plant that gives him shade, the palm tree away.
But you notice the whole inside of the saucer is palm trees.
Pretty much. Yeah, that's an interesting
That's,
ET movie.
that's the beings that are in there.
Yeah. Well, we all saw ET. It was here picking up stuff like that, I think, if you remember. And here are the 2 talking heads. Are these aliens or humans? This is the void, Charlie. We call
Any
it-
sentient being.
Oh, okay. We're looking up at the night sky. We call it the void up there, not because we know it is empty, but because we do not know what it is full of. Ooh,
What?
okay. You could insert a dirty word there if you wanted. That's okay.
It's a play on the fact that the vacuum of space is not a vacuum. So
Well-
particles come into existence and disappear all the time.
I suppose so. We may be
Well,
talking.
there's a really lot of interesting jokes about that, but there's also a lot of serious discussion. And a vacuum is technically defined as once you've removed everything from a section of space that you can remove, whatever's left is the vacuum.
Is that right?
But the vacuum of our universe, where the laws apply and stuff, is actually a elastic medium that's about 10,000 times stronger than steel in its spring constant. Otherwise, it couldn't transmit gravity waves.
Oh,
Do
wow.
you remember months ago when our speaker was a UCSB professor tied in with the CERN collider, Hadron Collider in Switzerland? Remember him?
Yeah.
I
company-
remember the talk.
I regret ever since we ended that for not asking him. Isn't that big long 17-mile tube that's round, buried underground? Is it vacuumed? Is it emptied of as much as they can?
Yep.
And then the electrical cords or coils around the tube would have to be positively charged to keep the protons in the middle, wouldn't it?
Well,
they
it's
do
a
it with
magnetic
magnets.
field in.
They do it
Yeah.
with magnets.
It's
like the
magnet.
magnets.
Okay. Well, anyway, I didn't get
It's like a
chance.
rail gun.
We'll have him back. We're going to have a young man from UCLA. I told you, Sahil Hegde. He looks good, looks friendly. And all I can say about the last speaker is I'm going to quote Forrest Gump. Life like booking science speakers is never a sure thing. You never know what you're gonna get. It's like a box of chocolates. Okay, let's look at Mars here.
Even when you get it, you don't know what you got.
You don't, you missed
Looks like
an
it's got
interesting
acne.
evening. Yeah, right. God, it looks sick. It looks like Io, not Mars.
Yeah, this is Mars taken by the NASA's MAVEN satellite. And this is it's in ultraviolet, so it's going to look strange. The colors here are, of course, false colors, just to tag things, which band they were in. But it doesn't look like what you'd normally see. It focused on the atmosphere.
If you can find it, huh?
Which is
The what?
mostly-
I said, if you can find it, it's atmosphere, their atmospheric pressure is like 3% of ours.
About 1%, I think.
Oh, wow, I know it's really low.
Yeah,
blown away by
but it's
the
enough to see there are clouds in the atmosphere, in the sky on Mars.
Yeah.
So these pictures, the first one was taken in July 2022 during the Southern Hemisphere's summer season, and that is when Mars is closest to the sun. It's in an elliptical orbit, obviously.
Maven, I'm amazed.
Somewhere they have the
Mars atmosphere volatile evolution. That's what that stands for, Maven.
Yes.
Okay. What, I don't remember that one. We got so many orbiters and probes, missions. It's just crazy.
So they're saying the tan color there is clouds and haze inside the crater, just above the polar cap there.
right
Very
here.
resolution.
Yeah,
That's the tan color.
yeah.
Okay, that's a crater in the middle, just
Mhm.
off the center,
The
right?
atmospheric ozone appears purple, has been assigned the purple color here. While clouds and hazes appear white or blue, so except this, the polar cap, but there's white stuff around here and blue stuff. The tan stuff is the surface, which can appear tan or green. That's where you're looking straight through the atmosphere. And that makes sense. These are more oblique views, so you're looking through more atmosphere over here. Here you're looking through the thinnest part straight to the ground. And the next one was taken in January 2023, after Mars had passed the farthest point of its orbit from the sun. So you have here in the northern hemisphere, which is this part up here, you have an abundance of clouds because it's cooling at this time of year. So the mission of MAVEN launched in November 2013 and in orbit on September 2014. The mission goal is to explore the upper atmosphere, the ionosphere, and interactions with the sun and solar wind. They're trying to figure out how much gas they're losing to the atmosphere due to the solar wind and the lack of Mars' magnetic field to protect it.
Is it as deep as our atmosphere? Does it have strato
No.
and upper? It's not hardly deep at all, right?
It has layers, but it's not nearly as deep.
Yeah, because it's not very thick at the surface.
Hmm.
Matter of fact, when they land on things on Mars, part of the process of entering Mars' atmosphere relies on aerobraking. And as these satellites, these rovers, I guess, get bigger, the aerobraking is less effective because the thing is so massive, the air doesn't slow it down as efficiently as it does, say, on Earth, or it did for the smaller payloads. So they have to design supersonic, what are those things? Parachutes. That so the recent one that landed up there, Perseverance, had a brand new what is it? Parachute. It's tough to get them to open. What's that?
One time they used big balls full of gas.
That's they called them.
Yeah, that was a very lightweight rover.
Oh, okay. They bounced their way across the Martian surface.
Yes.
Oh, that was different. Yeah, that one.
Yeah, that's the stuff now is way too big to do that, the balloons would pop.
Yeah,
So
that
you
was
get a very
Spirit and-
good
Spirit
idea
and
of-
Opp-
Okay,
Spirit and Opportunity were the two that they did that with.
Yeah.
you can get a very good idea of the thickness of Mars' atmosphere. The thickness of the pressure on on Earth, 14.7 pounds per square inch, is the summation of the pressure of, or the weight of all the atoms in our atmosphere going out to forever. And if Mars is like 1% of ours, then they've got 1% of the distance. Oh, actually, they've got carbon dioxide as the atmosphere, which is heavier. So, it's nothing.
Well, when a grain of matter comes into our atmosphere at night and ignites and oxidizes, and we see a meteor, does that happen on Mars?
What you see in a meteor, it's not the meteorite burning. The meteoroid is going at such a speed that it ram heats the air in front of it and heats the air up, and the air fluoresces.
The air, well, how can they, some of them burn up before they hit the
Yeah,
ground. So,
some of that heat can get transferred to the substance of the meteor.
but that doesn't
Meteorite,
happen.
meteoroid, and then you can get stuff ablated off.
So they get just as many rocks and things falling on Mars, and we just don't, you wouldn't see them probably, right?
Yeah, no, they have meteor showers there. There were pictures of meteors from Spirit and Opportunity.
So oxygen is not involved in what we're
No.
seeing at night.
That's
Really?
correct.
Be darned.
Well, I mean, it's involved because it's in our atmosphere, but
Yeah.
it's not specific to oxygen. It's whatever gas you have there that gets ram heated.
Okay. But you have to have some kind of atmosphere for anything to be seen on.
Yes.
The moon, you'd never
Yeah.
see anything coming in, would you?
I'm guessing that because Mars is closer to the asteroid belt, they probably get more objects than we do. But when you pass through the orbit of a tail of a comet, that's when you have a meteor shower. And that's when the dinosaur starts breathing into the bag to try and lower his anxiety. So, yeah, go ahead. Oh, that's right. A friend of mine got his PhD from University of Georgia, the Georgia Institute of Technology, in parachute technology and the mechanical dynamics of parachutes. Then he went to work for JPL, working on the parachutes for the landers on Mars. And then he transferred to writing the software for the helicopter on Mars. So he would be a good candidate for a speaker at some point, I think.
Yeah,
So he helped build the Ingenuity.
software.
I'm not sure about, the Ingenuity is the helicopter. Yeah, he programmed and planned the trips that it took.
And my understanding, it's got two rotors, one on top of each other, that go different directions.
Counter rotating, so it doesn't need a tail.
It doesn't need a tail, and they're going super fast because there's so little atmosphere on Mars.
Yep.
Super
And
fast.
Ingenuity is kind of conking out because the solar panels are accreting dust
Where would they be? On the blades or on
on the top, above the blades.
Oh, I see. Okay.
You'd
Well,
think they'd learn. I mean, how many times has that happened already?
Well, the rovers have the RTGs, but I think that's a little too heavy to put on the helicopter, so they were
Right,
stuck.
the previous rovers, they had to wait for storms on Mars to help clear the dust off their solar panels.
So they don't use windshield wipers.
No.
I'm surprised they don't do the same thing that they do in our cameras, which is to have an ultrasonic transducer, if you will, a film on the sensor itself, and they literally blow the dust off the sensor.
You shake it off.
Shake it off,
Shake
right?
it up, baby.
Yeah.
Oh, yeah,
I don't know if they build up as strong a static charge in a camera sensor as they do on those panels, though.
So the
Right.
design lifetime for our rovers is around 90 days.
Is that right?
And they're exceeding that by many orders of magnitude. They're lasting approximately 10 years. And they eventually die primarily because of the dust on the solar panels for the first ones. And then they get dust in their wheel bearings and they get stuck for that. But they exceed, they didn't plan on maintaining them on site for long periods of time. That extra time is just fortuitous, I believe.
But they're gonna try for more crazy landing sites, aren't they, with mountains and hilltops, sides of craters,
Mhm.
and on the equivalent of our deserts, pretty much is where they land these. Here we go, out to the other moons. Saturn with Iapetus. Iapetus, come over here to the party, for crying out loud. You don't have to bring Jerry a gift for his party.
Now, this is tomorrow evening at 21. So that's 9:30, 9:40.
So Saturn won't be up.
Right.
Yeah.
But this
But-
moon is bipolar, isn't it?
Oh, Iapetus. Yeah, this just shows it way out there. It's one of the a large orbit one. We're going to look at two particular ones: Iapetus and Enceladus. Enceladus.
Mhm.
Enceladus is here. Iapetus is way up here, and the thing about Iapetus is that Iapetus is the moon that is essentially black on one side and white on the other.
But I said bipolar. That was a bad
Yeah,
day.
you could look at it that way. White is the color of the snow and ice on it, and that's the natural color of the moon. This, it's picking up debris. It's as black as carbon. It's very enhanced here. So it's a heavily processed image. But the moon is tidally locked to Saturn. So if you follow Iapetus around in its orbit, when it's to the west of the when it's to the western elongation around Saturn, you're looking at the white side. And when it's about half and half, when it's at superior and inferior conjunction, this means it's between Saturn and us. And here it's Saturn is between us and the Iapetus. And on the eastern elongation, we see only the dark side. So it changes by several magnitudes. And that can be, at first they noticed in their small telescopes when Cassini saw this, he was the first to note this phenomena, and that it was, and he guessed that it was tidally locked from that. They didn't know why it disappeared, but they noticed that this correlation, you could really only see it in the western elongation. Now with our amateur scopes that are much larger and with taking pictures, we can measure it photometrically, and we can see the difference in brightness of the two sides.
But
So it looks like it has a variable star for a moon.
which of those sides faces the planet?
The planet, this is what the planet sees at this time. And the other side, it also sees this side because it's tidally locked, remember. So this is what it sees. This is what Saturn sees all the time.
Half
Okay.
and half, or what, or all black or all white, or half and
No,
half?
the half and half, the part.
Half and half.
Half and half. And it never changes. That's what tidally locked means.
Not from Saturn, but from us. It's not tidally locked to us.
I'm imagining living on Saturn in a boat.
And
traveling
that
around.
dark patch is the leading edge of the
Likely.
moon in its orbit. And so
Yeah.
it's getting bugs on its windshield. They think pieces on the way in. The Cassini orbiter saw a moon called Phoebe that had lots of polycyclic aromatic hydrocarbons on it. And those are dark. Those are like the gunk on your barbecue. And it seems to have been eroded by multiple small impacts, and that sprayed a bunch of this dust out there. And this moon is passing through clouds of that, and it gets splattered on it.
And we didn't know about this until Cassini discovered it.
No, Cassini, the astronomer, saw this happening, that it was dark and light and dark and light.
Really?
But it was the Cassini orbiter that figured out, some of the chemical composition of it.
Back in Cassini's day, he had an old-fashioned telescope that would show him that much detail, black and white. It would just be a little sparkly.
Oh,
dot.
No, he saw that it varied in brightness, and he inferred from that it was tidally locked.
Oh, I see. Got it. And Enceladus is the one they're looking at for possible life. This one doesn't have much chance, does it?
but we'll get to that in a second.
Aha,
The
jumped the gun.
Iapetus is bright at magnitude 9, and it fades to over magnitude 10. So both of them are not visible to the naked eye, of course. And a 6-inch telescope can see under really good conditions to magnitude 13. But I don't believe Cassini had available anything bigger than a 2-inch scope. So a 2-inch could reach the 9 and possibly the 10. But they're just taking in impressions at the very limit of their technology at the time.
Well, they probably had a lot of distortion in their scopes too.
They could. Well, no matter what happened, he's only going to see this as a point, a brightness like a star. There's no surface that he could see.
One of the scopes that he used, they couldn't, they had one kind of glass. They hadn't learned about apochromats. And so they had refractors and they had only one type of glass. So if you look at the shape of a lens, the edges of the lens are basically prisms. And so you get this chromatic aberration. But they found they could make bigger lenses and stop them down so that you were just looking through the central part. And you make them longer focal length. And so that would minimize the chromatic aberration. So they were looking through telescopes that were 100 and 200 feet long. And you can't make a tube that long and keep it straight. So what they did is they mounted the objective lens high up on a tower with a swivel so they could move it around. And they attached a cable basically that was 200 feet long or whatever to a handpiece that had the eyepiece in it. And then they had to try to pull that line taut and then aim the handheld piece until they were looking through the objective lens. So these guys were really patient and taking a lot of effort to look at these things.
How long after the guy that got shot down by the Catholics, good old Galileo, how long after that was this? Another 100 years, 200?
Within 100 years or so.
So he had improved on Galileo's.
Everything was an improvement on Galileo. He couldn't even tell the rings of Saturn were rings. He thought they were
big ears.
Yeah. So following up on Chuck's comment, the moon, the dark matter is estimated to come from, or most likely comes from the moon Phoebe. And it's due to impact collisions. Now, so that's something to note about that. Here's the moon Enceladus, which is a moon of Saturn, and it sprays icy material, water out of it's basically frozen water on the surface with a salty ocean underneath. That's the current view of it. As the spacecraft went by, it imaged, let's see, what is this? Oh, this is the spacecraft Cassini, imaged these geysers coming off here.
And they just recently detected phosphorus in these geysers, which is good news because it's a component of DNA and all kinds of life processes.
So they think all the good stuff is out there for life.
Yeah.
Yes, it's everywhere.
But what causes the geysers? What makes that? What goes?
Geysers are water vapor.
It's salty water.
Oh, okay. It vaporizes and becomes a gas and then immediately freezes probably.
Yeah, it's just like, Old Faithful in Yellowstone.
Got it.
Yeah. This is another case of a cryovolcano, the ice volcanoes.
Yeah. So this is, there you can see a couple of the geysers there. This is the James Webb Telescope looking at the detected water in infrared. And this square right there, the moon is right in there. And all this is that plume coming out. That plume is about 9,000 kilometers long.
So that little moon's shrinking over time, isn't it?
I don't think by very much. You get a lot of push out of just a little bit of water into space. It creates quite a dramatic spray.
Yeah, Ron, somebody estimated, remember Comet Hale-Bopp and how spectacular the tail looked?
Right.
That if you took all the material that was in the tail, which was millions of miles long, and you compressed it down into a solid, it would fit in a suitcase.
And yet they're dust particles, or are they just molecules?
Well, molecules of water and dust particles. And in Enceladus case, probably not a lot of dust.
Well, you know what I wonder about it? You suppose it's a universal thing that if you're going to have a lot of water on a moon or a planet, you're going to have the damn salt in it, pretty much.
Yeah, water dissolves all kinds of stuff.
But when it evaporates and comes back, it's fresh. It
There's
doesn't
a
have
lot
any-
of faults. These are ice flows that are continuing to move around and rub against each other and break open. These are like continental drift on Earth.
Yeah,
But
and
here
Ron,
it's with rock.
that water's not getting boiled or anything. It's getting sprayed out. So there's salt
Yeah.
in the plumes too.
It's pressure.
Yeah.
And
Sorry,
so it
Jerry.
doesn't recondense and fall back down to Enceladus's surface. There's no way.
Some of it does, but it's
Yeah.
not recondensing. It's just gravity pulling it back down.
The conclusion of the study that I took this from claims that nearly a third of the molecules that are sprayed out into that 9,000 kilometer long plume are fed into a donut shaped ring around Saturn.
Donut shaped? Well, all the rings are donut shaped, aren't they?
Well, no,
No,
they're pretty flat, most
Yeah.
of them.
Oh, this one's got some substance to it, like our Kuiper belt.
Well, yeah, more like our asteroid belt, but yeah.
Okay, got it.
Does that mean then that Enceladus picks up some of the stuff that's sprayed out on its next trip around?
Yep.
Wow.
And that was one
It
where
also
they got a
means-
good image of it when Cassini got on the other side of Saturn from the sun.
Uh-huh.
So you got the forward scattering effect from the particles, and you could see this big donut shaped ring out there.
This also implies there must be currents in the under ice ocean.
Yeah. It's getting squished and squeezed.
You know, I've spent time in the Arctic, and you get pressure ridges up there. Big sheets of ice move and you grind against each other, and
Yeah, that's exactly what's going on here. Pressure ridges.
yeah.
Well, if we land a lander on this little moon, how in the world is anything rocket-like going to be involved? It can't have any heat, can it? It's going to have to bounce with balls, or there's no atmosphere, so it can't use a parachute. How are we going to touch down on Enceladus?
Retro rockets.
You can use rockets.
Yeah.
You have the heat of I forgot what the solidification, whatever it's called. It takes energy to turn frozen water, for example, into liquid water. That's why you can put ice cubes in a drink, and the drink stays at 32 degrees Fahrenheit.
Retro
Same thing
rockets don't
here.
use it. Are you saying retro rockets don't use energy?
Yes,
No,
they do, but
they-
the ice will absorb the energy. I mean, I don't know how cold the ice is, but you got to get it up to its freezing point before it turns into water. And it takes a lot of energy to do that, to turn it into water.
Wasn't there a plan to land something that was nuclear, that would have a nuclear reactor and sink down into the damn thing? Was this?
That was on Europa, one of the moons
that was
of Jupiter. They were talking about having a heat drill, basically, that would go down through the upper crust.
But if there's a world of living beings in there, they have no idea, assuming they have any intelligence at all, that there's a universe out here, never seen a star. They don't even look at Saturn, do they?
They're definitely not stargazers, and they probably do not have an astronomy club.
Yeah.
Incidentally, Jerry, you sent us an interesting thing about another club that's like us back
Oh,
east.
yeah, that's something that it's on Facebook. It crops up now and then. Yeah.
I'll have to check
What
with
is it? Astronomy by the Bay from New Brunswick.
Oh, way up in Canada.
Yeah, they do a video blog like this on Sunday evening, which I've seen a couple times.
Is there okay? I'll check into them. Maybe he'll get us a speaker. What are we looking at here? Jupiter.
Well, I don't think we can afford to fly one of them out here, but
Well,
we're moving on to Saturn just as a moment. There are interesting moons here, but this is the pattern that you'll see tomorrow night at what is that, 11?
That's 10:20, but again, it won't be up.
Yeah,
No,
Jupiter
yeah.
up around 3 in the morning. I
Yeah.
saw.
I went to bed
Yeah.
at 4:30
Oh,
this
it says
morning.
no, Jupiter comes up now at 2 in the morning, according to the Sky Telescope.
I
According,
went to bed at 4:30 this morning, and Jupiter was up quite bright in the eastern
Yeah, it's a
sky.
morning object.
Yeah.
Europa, Io,
Well,
Ganymede, and Callisto. We'll get into details of those moons on another version of this.
but those you can see even in binoculars, so that's cool.
Yes.
Hey,
And
there's a moon.
people
There's our
have
moon.
claimed that they've seen them when they're spread way apart. They've picked out some of them with naked eye.
Yeah, I think it's Callisto because it's the farthest out.
Yeah.
If you're a child and you have good vision, not an adult, but if you're a child with good vision, if you block Jupiter with something like a power line,
Mhm.
that's suspended in the sky, then there's a chance that you can detect Callisto at greatest elongation.
I think a more useful thing would be the branch of a tree. If you're blocking it with a power line, you're probably in the city.
Yeah, yeah.
Okay, this is the moon tonight, 26 at 8:40 p.m. Just past first quarter. Very interesting part of the moon down here. One that when I was starting out, I took a lot of pictures of this region in here. These are both from a planetarium software. They're not pictures. But these this triplet of craters together, along with the straight wall, is very visible tonight. This is the terminator over here. So it has just swept past this. This is Ptolemaeus. And when the sun is real low across there, it is loaded with undulations and things that you can see at low sun angles. This is Alphonsus, and this is Azakel,
Arzakel?
or something like that. Yeah, I always have trouble with that one. So it's a good start.
Albatignius is also very good to look at.
The what?
Albatignius. That went low sun
Yeah,
angles.
right there.
Yeah, I know. I saw that. Right.
Yeah,
And the
It
straight
autographed
wall is
you.
fun. It looks like a sword there.
it does. Yeah. Or now it's a great umbrella,
Yeah.
all folded up. It looks like it was called the straight wall when I was a kid. We thought that, and it was represented in movies as being a very vertical cliff. It turns out it's just about a 60-degree slope.
So what we're looking at is shade or shadow.
Yeah, shadow.
The Uruguayan bird from
This is
hell.
very interesting. Yeah, other cultures have other constellations and other folklore about it. This is, I don't know what you'd call this, whether it's their constellation or it's not. It's an asterism, but boy, it has a lot of stars in it. So
Yeah. This is the Aboriginal emu, isn't it here?
Yes.
Yeah.
It's got a name starts with an N.
yeah, it's Nandu in
Nandu.
Uruguay.
Yeah, the Milky Way bird.
And Nandu's footprint is supposed to be what we call the Southern Cross asterism.
Which we can't see.
Not from here,
Australia.
but if you were in southern hemisphere, you could see it.
But it's over the bulk of the Milky Way, right? The
Yeah.
slender edge
They
on.
use the dark clouds as part of the constellation too.
I'll be damned.
Yeah, and it now, once I've had this shown, now I see it in these. So
Yeah.
very interesting.
And that hasn't
Um,
changed in thousands of years, probably.
This photo is from the APOD for June 20th of this year, 2023. It's taken by an amateur Fefo Bouvier, the line drawing by Alfonso Rosso in Cabo Polonio, Uruguay.
Which is an indigenous tribe or a,
This
No,
is this is a statue, a monument.
oh, that's a statue there.
Yeah.
But the asterism connotes to me that maybe they have others. They have their own constellations or asterisms up there.
Every culture around the world had their own constellations.
Yeah, they were not troubled by lights of cities, and so they looked at these patterns, and the human mind puts things together into asterisms and patterns so they can remember them easily. It's a mnemonic of ours.
Okay, well, the Greeks or the Arabs missed this one, didn't they?
Mhm.
Well, they couldn't see most of this.
Oh, really? They're in the same northern hemisphere we are.
But this is the southern
No,
hemisphere.
no, They are, but this is Southern Hemisphere run.
Oh, is this the view they get that we don't get?
Yes.
Oh, I see. Okay.
We can see this part upside down on the southern horizon, but we don't see this part. Because
And
the
emus-
South Pole is way up here.
Okay. Emus are pretty large birds, but they're not indigenous to South America, are they?
Right. This is showing you the Aboriginal constellation. I don't know if the Uruguayan Indians had their own version, but they can see it.
So the
Okay,
statue is one of Maria Micaela Guayanusa, an indigenous woman of the Charu people
Okay.
who lived in the 1800s.
That little black figure is a bronze.
Yeah, and endures as a symbol of colonial resistance in Uruguay.
Wow.
Okay, so they must have had a similar constellation, and they have Reyes or some other large bird like that down there. So that's probably what their version was.
Okay,
All right.
now this is, I'm showing this because it's a variable star that people have been working on for quite a while, and they have no explanation of how this is happening. It's at least a double set of stars, a brighter and a dimmer star, because you see, and it's an eclipsing binary, because here's the eclipse when the smaller one is going by, and here's the eclipse of the bigger one, so it drops it. But normally these lines would be flat between the two in here. But why these are tilted, they're trying all sorts of different combinations in modeling, and so far they have not been able to determine what, with any reliability, what the account for the photometry that we're getting with this. They've even gone so far as to look into something called the Applegate mechanism, which is one where eclipsing binaries are constrained by very strong magnetic fields that constrains their emitted gas into jets, but that doesn't fit. So they have no answer for this. So here you're looking at a mystery in process of being explored.
And they were postulating all kinds of, exoplanets to modulate how these things orbit around each other.
Are they close to each other and going really fast?
That's up for speculation.
Yeah, I don't wonder what the units are on orbital phase.
Well, that's 0 to 100%.
Yeah.
Oh, okay.
Not
In
miles.
2012, it was claimed that 2 giant planets were in orbit around this binary with masses of 2.9 and 8.1 times the mass of Jupiter, orbiting with periods of 3.5 and 6.9 years, respectively. Another paper claimed the existence of 1 planet with a mass of 12 times that of Jupiter in a 20-year orbit. However, subsequent studies have come up with different results, with masses up to 15 times the mass of Jupiter and periods of 8.83 years. So that tells us they haven't got an answer yet. So they're trying to fit this curve with all these made up computer simulations. So watch this space.
Yeah.
Well, is there a picture of it?
No. Well,
No
it's just a
photo.
dot.
Okay, but those planets, they think orbit both stars or just one of them, like Alpha?
Both
Centauri?
stars, yeah.
Both of them. Wow, that must be a heck of a trip.
Mhm.
Okay, more diagrams.
This is a supernova in M101 we've been looking at for a while, and I believe Chuck has shown it to people in the outreach in the intermediate time.
Yeah.
This is the photometry of it in 3 different bands, red, green, and blue. When things are hotter, they're blue. When they're not so hot, they're green on this. And when they're cooler, they're reddish, they're red. So you can see it's cooling off slower in red, and it's cooling off faster in the hotter regions of the star. And the reason for that is because as this thing cools, radiation from a hot object, the black body radiation from a star, not looking at its lines, but at the colored background, as an object cools off, the peak output goes from visible to the borderline with infrared, and then into the infrared, and then into the deep infrared as it cools from, say, our sun, which is about 6,000 K, And if our sun were to cool to 3000K, the total output would drop, and the maximum amount of the peak of the output would be down in the near infrared at about 1.2 microns.
And we've been ice cube.
So yeah, so what's happening is as this supernova cools, the peak is moving down. So there's a bigger change in the photometry looking at the yellow band, and this does not correspond to the colors on the other one. But if it stayed in this band, that would drop down, the peak would move out so that this one would drop down to here, and this one would drop from here to here. So the bigger changes come with the higher heat output. And that's what you're seeing with this photometry. It's a normal black body cooling. This is done by an amateur.
Really?
The last time I showed it to people was at Refugio on Friday night, I think it was.
Uh-huh.
And it's still quite visible. It's definitely dimmer than it was the first time we saw it, but it's still quite visible, at least in whatever pass bands the Melancam is sensitive to.
And yet we don't have a picture on our screen.
If you have a Melancam with a filter in it, an infrared filter, then it looks like a regular camera. But a lot of these astronomical cameras don't have any filter in it, and so they see into the they see from the visible band, and then they go out to about, silicon cuts off around 1 micron. So they can see out to the infrared a little bit. It drops off quite a bit as you go out. This is the hydrogen alpha line in this red band in here. And this is why you can't get a good clear focus with some cameras if you're looking through a refractor, because refractors made primarily for visible use don't bring the infrared to the same focus as the visible. So to get really good looks, you need primarily a mirror.
But this is different from how most supernovas cool down?
No, this is typical. I'm just
Oh, this is
explaining the
typical.
physics of why the one band goes down more than the other.
And this is in M101. It's not 101 itself.
That's correct.
Messier. 20.
M101 is the Pinwheel Galaxy. It's a big spiral, but low surface brightness up in Ursa Major.
Yeah.
Okay.
Now this is looking at the summer triangle again. The picture I had last week was so bad. So here it is with Deneb,
Vega.
thank you, and
Altair.
Thanks. So much for those glasses. They didn't help. So
New comet.
yeah. So anyway,
Somewhere there is a comet called.
not in there. No, this is just a feature that I threw in because we did
Oh.
such a bad job last week. But here's the wider field of view. The summer triangle is not highlighted here, but this is featured on Altair, which is down in this region. So now we're looking down in this region here. And this red bullseye is where the comet is on this date.
So lower wing of Aquila. Yeah.
Yeah. And it's not a bright comet. It's just been discovered. You're going to need it's about 12th magnitude right now. It appears round, almost like a tiny galaxy. There's no tail on it yet, or there's no prominent tail.
And if you need a name, 237P Lineaire.
Yeah.
So that's the guy's name that found it.
Well, that's the Lincoln Laboratories Near Earth Asteroid Search Project.
I knew that, Chuck.
Yeah.
You-
And the P means it's periodic, so it's a short period comet.
So there's no date on that. Just 237 means it's your 237th they found, I guess, right?
It's the
They
date is
calculated
coded.
the orbit for.
Yeah.
And they know without a tail that it's a comet. Isn't that amazing?
It's moving.
Oh, is that
So
way?
this is tonight at 10:30. It's not moving very fast, so this will count for you all the rest of the week.
have they calculated where it's going? Is it gonna come inward and
Yes.
give a tail?
They have
Yeah,
made
it's-
predictions about that.
Yeah, it's got P/237, which says they've calculated the orbit and they know it's periodic.
Wow. Some of those others we talked about months ago, they're gone.
Yeah,
No, well, they're still there, but
but
not
they're
prominent
dim
right
and
now.
they're moved out. Yeah.
Okay. Wow.
Okay, we're gonna skip.
Well, wait,
Hercules
just a
and
sec, Jerry.
M13.
Well, go ahead and finish stuff. There's just a bad astronomy joke there in part of this image.
Go ahead.
So you see Delphinus there, the dolphin off on the left.
Yeah,
So you see those two stars, Suellison and Rotanev.
Yeah.
Okay, so the sort of astronomy joke is that there were some students of Piazzi in Sicily, and a lot of these stars are double here in Delphinus, and so they were studying double stars, and they realized that those two stars didn't have names. Okay, and their teaching assistant, who was Piazzi's assistant, was named Niccolò Cacciatore, and they said, "Hey, let's name these stars after our mentor here." So they said, well, okay, what's his name is Niccolò Cacciatore. That's way too Italian. What does that mean? It's, Nicholas the Hunter. And so they said, okay, well, let's take that in Latin. So they got Nicolaus Venator. They said, that's still too obvious. So then they spelled those things backwards and used the names of the stars. We have Suellison and Rotanev. But actually, it was a joke totally. It was a story totally made up by Piazzi, and he named those stars after his assistant.
okay.
Gotta tell you, Chuck, there was a time I'd call you a walking encyclopedia. Now it's a walking Google. I'm sorry.
We call him Mr. Astropedia.
That's true. You're right. All right.
Most people leave off the subsequent syllables.
Okay, what is this connected to, Mr. President? This is our solar system, obviously. It's not.
Yeah, I was looking at Venus and the phases of Venus, and I came across a website that showed these different historical cosmologies to explain why Venus looks the way it is. And they had a very bad image of the Copernican or the Ptolemaic system. They had, it's hard to reproduce in my mind now. So I dug up the real ones. Someone who put that graphic together on that website didn't understand astronomy. But this is the old cosmology from Ptolemy. It's called the Ptolemaic universe. And they could see 5 planets in the sky. So they knew about Mercury, Venus, Mars, Jupiter, Saturn. And they had, and obviously the sun and the moon, and they could see Earth. They were standing on it, and they figured that we are the center of everything because you can see the things go around the Earth, so to speak. Not quite in this way. They went in hypocycloids, which they didn't explain with this worldview. And this is the fixed realm of the stars out here. And because they never saw any of those move, and I guess these are orbits reserved for future expansion. But Uranus, Neptune, Pluto, the planet X, and then Tycho came up with his system called Tychonic. And here is the Earth with the moon going around it, and the sun out here going around the Earth, and Mercury and Venus going around the sun, and Mars and Jupiter and Saturn going around the Earth in big orbits.
So that was after Galileo saw Venus going through phases. He could tell it was orbiting the sun. And this was an attempt to explain that, but still keep the Earth at the center.
Yeah.
But notice the outer planets are not, those circles are not concentric about the Earth, they're concentric about the sun.
Yeah.
So he snuck that in, I guess.
So it's halfway there.
Can you go back to the last diagram, the Ptolemy one, just for a second? Jerry?
Yeah,
there it is.
What are the dots in the middle?
Stars.
These are stars.
The stars, they're in the middle?
This is the realm of the fixed stars.
Okay.
They thought these lines represented these crystal spheres
Right.
the bodies were embedded in. and they were rotating.
I thought for a second there that was their asteroid belt, but
Yeah.
they wouldn't have known about that, would they?
I don't think that they believe stones could fall from heaven.
Well, it's in the Bible. They get what Hannah and other things for, or manna. What's that stuff?
Yeah, but that was
Fire
manna
and
is a what is it? It's a organic molecule similar to spoiled butter.
Yeah, well, fire and brimstone came from the volcanoes, I guess. Okay,
So then Copernicus published this on his deathbed. And this, of course, is the proper one.
right.
The Mercury, Venus, Earth, and the moon.
Well, it's
And then
almost
Mars.
proper, except he kept all the orbits still circular.
Yeah.
No, he wasn't condemned though, was he?
Too
That's
late, he died.
Published it till he died.
Yeah, he didn't have a book signing,
Yeah.
Okay, gotcha.
but he
Well,
wanted to avoid all the conflict that we had with, or that Galileo had to endure. Now, this is not our galaxy, but it's one that looks like our galaxy. Let's see, do we want to do that? Let's skip this for a second because we might not have time. Well, no, we'll stick with this. As some of you know, the James Webb has seen a lot of really big and really bright things that might be galaxies at very high redshifts, very far back in the first 300 million years of the universe. And a group has been studying our galaxy and other large galaxies that are pretty pristine, and they regard our galaxy as one of those. And this is a picture of another one that they used as an example. It's NGC 4013, and it's called a perfectly edge-on galaxy. But the thing they're saying about that is that this and other undistorted galaxies are some of these very big objects that started very early in the universe. Our galaxy became very big and has not had any significant collisions or gravitational events with other galaxies, and it retains essentially its pristine form. Of course, that's about to change in the next 5 billion years when we run smack dab into the Andromeda.
Sucked
But
up
they
some of the local group, haven't we?
What's that?
We've sucked up some of the little ones.
We've sucked up a lot of minor ones and
Yeah.
drained them, dwarf galaxies, yes.
And this makes us unusual, oddball.
It makes us unusual, yes, according to them. It's they had a very large sample of 61 such Milky Way analogs, as they call it. They form disks when they've become massive, they form disks. They congregate into clumps, and then they form disks at a certain turn-on point in mass. And then our galaxy and others like it have had a relatively quiet lifespan. Now that leads into another thing about the Drake equation, about possible conditions for advanced life. It's true that stars don't actually collide with each other when galaxies merger, but it might be there might be a Goldilocks zone in these galaxies in which life exists. And this study ties into looking into that larger issue.
Yeah, and mergers would cause births of supernovas, and that causes births of radiation. So that's part of that Goldilocks zone thing.
Right. This will be very quick. This is the biggest star yet found. It's a red hypergiant shown there.
Carl Stevenson 218.
Yeah, and this is the size of it compared to the orbit of Saturn.
Oh my God.
And compared to other stars, La Superba, which we've discussed before, UY Scuti, Betelgeuse, Myra A. There's
Another Stevenson.
Yeah, another Stevenson. And here is where it's located. This is Alpha Scuti, M11 in Scutum, Beta Scuti, M26, and right up here is the star cluster, Stevenson 2, that star is located in.
Betelgeuse is
I
not
wonder
one of
what its mass is compared to our sun.
it showed it there, didn't it?
Yeah, I got it buried in here somewhere.
Ron, that
like
was just showing the
Betelgeuse, it's like-
size.
Betelgeuse is like 20 times the mass of our sun, something small.
It's like 12 or 15 times the mass of our sun.
Yeah,
Yeah,
right. It's very gaseous. It's very tenuous.
fluffy.
Yeah.
Huh,
Fluffy, yeah, that's a good term.
wow.
Don't have the mass, but it's 440,000 times the luminosity of our sun.
Oh, it's so big.
Yeah.
Did you mention Betelgeuse? Is it among those biggest?
Yeah, it's there in
it
the, in
is.
the diagram.
Oh, I see, okay. Betelgeuse is ready to go any minute now.
Betelgeuse is right there. This one will be a hell of a supernova, hypernova when it goes.
And they're usually red, aren't they? Red giants. Are there
Yes.
such things as blue giants?
Yes,
Yes.
but they're much smaller.
Okay, smaller, but still giant and very hot.
Very
Yes.
hot.
And probably young and long-lived, or they go out fast.
No, they
young
burn
and
hot
short-lived.
things. Hot things burn fast.
Yeah, 10,000, 10 million year life rather than a 10 billion year life.
Yeah, 1,000-to-1 ratio at least.
Yeah.
You're gonna try to get in the Oort cloud, aren't you?
Oh, it's just a pretty picture. There's not much to say about it.
Well,
It's a
let's
very
talk
nice
about-
graphic showing our solar system at the middle. And for scale, this is out here is the Kuiper belt right there, which is a flat zone. And then this is the part of the structure our sun is in that hasn't flattened out yet.
Do they think every star has something like that?
I would guess yes.
Many,
don't think-
at least many stars.
Yeah.
So Alpha and Centauri would have one, and the other two stars are, is it a trinary or a binary? Centauri system, that's,
It's triple.
Yeah.
so it'd be one big, huge Oort cloud around the whole three, or just each individual has its own
Yeah.
shell, you suppose?
Well,
no,
go ahead, Jerry.
Oh, the three of them would be at the point here. So this would be around the shell around the triple system.
Yeah,
Gotta-
multiple
would-
systems complicate things.
Yeah, the fact that there's three suns at the core and they're separated by on the order of a light year, this thing would if each one had its own Oort cloud, they would have all joined a long time ago and formed some more complicated structure possibly.
Gonna find a lot of stuff out there over the years to come. Gentlemen,
Yeah.
can we continue this conversation later on out at near Winchester Canyon and
Yep.
have our drag races with the Teslas in the street? And don't bring a gift, just bring an appetite. And congratulations, you're right on the borderline. Next year is really gonna be special, big 8-0, but
Yeah.
we'll meet again, and I love it. That was number 123. We'll get back together and teach the Baron what he doesn't know next Monday morning. Well, that'll be the 6th or 7th and 8th. No. What are we talking about? The first meeting of the month of July is the 7th. And it'll be followed by our second Saturday get together at, I guess, if we have a day like today, we're going to do Saturday Star Party.
Absolutely.
All right. SBAU.org. We'll see you on the radio and on, no more radio. I'm sorry. This is a new version here. Can you guys see this on your screens on your Tesla front screen thing there?
I haven't tried. I don't know.
Well, don't, you'll have an accident, gentlemen.
You
Yeah.
could.
You could easily.
Well,
let's just,
it depends on whether they let you download Zoom or not.
I got you. Well, let's do it again next week. Thank you, Bruce. Thank you, Tom and Chuck and Jerry. Happy birthday. We'll see you tonight and next week again on